Rigid insulation foam, or expanded polystyrene foam, is a material used in the construction industry as a building insulation. It's sold in most big box hardware stores in the construction supply aisle. It's sold in 3 sheet sizes and many thicknesses. 2 foot by 8 foot sheet in all thicknesses, 4 foot by 8 foot sheet in multiple thicknesses, and 2 by 2 sheets in the thinner thickness. We are not using it for insulation, we are going to get a bit more creative with it. The film and stage industry used it for set and prop design because of its ease of workability and low price range. Cosplayers love it for the same reason. It's easy to carve complex shapes, it's lightweight, it's easy to paint, and it's easy to get. Tabletop wargaming and railroad terrain builders also use it for its ease of carving and painting and accessibility. As industrial designers, we are asked to create objects to interact with. Insulation foam is an invaluable tool for us to develop form factors of our sketches for our clients to interact with quickly and cheaply. As an industrial design student, you will be asked to prototype your sketches in foam. This will give you and your professors a chance to analyze the design's form factors, size, and ergonomics, and give you an opportunity to make changes for the final submission. Insulation foam is a wonderful tool. You should get comfortable with it. It allows you to work in both small and large scale. It's easy to work with and using the most basic of hand tools. And with some imagination and time, you can create some incredible shapes. Let's get into it. The foam is available in 3 colors. The colors represent 3 different companies, and they have no bearing on quality or workability. Each of the big box stores carries a different brand, so get the one that is most convenient for you. They're all the same. The foam sheets are available in multiple thicknesses. Choose the one that is most appropriate for your project size. These sheets can be glued together to achieve thicker blocks. Now that you have foam, let's talk about all the ways you can cut it. The most basic is a very sharp utility knife. The sharper the better. A metal ruler is also very useful, although you can cut freehand. Get lots of extra blades because the foam is very abrasive on the knife blade, and you will use them up. Let's start with this thinner piece first. Extend the blade from the knife just long enough to go through the foam, a tiny bit. Any longer and it will be too dangerous. If the blade is too long, it can snap while you're cutting. You don't want that to happen. Whether you use a ruler or freehand the cut, you're going to want to make multiple passes to get through. Don't try and do it in one go. It's too difficult to cut that much foam with that thin a blade. It will give you a very bad cut and possibly snap your blade while you're cutting. You're never going to get a smooth cut with a knife, so don't worry. There'll always be some roughness on the edges. That's what sandpaper is for. Let's try cutting something a little thicker. This is 2-inch. This is about as thick as you can go with the utility knife. Again, extend the knife to just past the bottom of the foam block, and then lock it into place. The thicker you get, the more cuts you're going to need to make, so take your time going through it. As you can see, the edge is okay, but it's not super smooth. That's about as good as you're going to get with a utility knife. If you need to break down larger blocks of foam to a workable size and the knife just won't cut it, here are some other hand tools in the shop that might work for you. A coping saw, usually used for wood, but works great for cutting foam quickly. It has small coarse teeth and cuts fast. It may not leave a nice finish behind, but it gets the job done, and for cutting down blocks, it works great. Next, we'll use a hacksaw. Although it's only meant for cutting metal, its fine teeth are perfect for cutting foam. Despite its fine teeth, it still leaves a rough surface behind. A keyhole saw has very coarse teeth and is meant only for wood, but it will work. This will leave a rougher surface behind than the previous two because of its coarse tooth design. Let's say you have a really big, thick piece of foam. It's too much for a knife, and the other saws won't work. Try a ripping saw. Meant for rough cutting lumber boards, this eats through foam very aggressively. Just keep in mind, if a knife won't cut it, any of the wood handsaws you find will do the job of rough cutting down foam into more manageable pieces. Sometimes the foam will be too thick for knives and handsaws, or the cut might be too complex to do manually. For that, we're going to need more power. The bandsaw is perfect. Although the bandsaw's teeth are more aggressive than all the handsaws that we've used, it makes for a smoother cut. That's because the blade is moving so quickly to the material. A bandsaw will give you a cut that is perpendicular to the table. It gives you a lot more control and allows you to do straight or curvy cuts much easier than a hand tool. The saw glides through the foam so easily that you can make really sharp turns smoothly. So when your project becomes too thick to cut with the knife or the handsaws, or you just need a more accurate cut, the bandsaw will make quick work of it. This next tool is not a requirement or even necessary. It's one of those nice to have tools. It's a handheld hot wire cutter. It's a handle with a very thin metal wire stretched across two arms. The wire heats up using electricity, and you're essentially cutting or melting through foam. You will need a power source for this to work. This version has a temperature control on it. To operate one of these, you're going to need a face mask that uses special filters that filter out hazardous fumes. The hot wire cutter melts the foam as it cuts and creates a very toxic fume. You're going to want to protect yourself against it. You should work in a well-ventilated space. Having a fan nearby is recommended, or close to an open window if a fan isn't available. This cutter will melt through the foam and allow you to cut very elaborate shapes. The handheld ones are not very accurate and have a hard time cutting straight lines. It does, however, leave a nice edge after cutting. It's great for organic sculpting, but if you were looking for accuracy, you're not going to get it. It's hard to cut thick foam without boosting up the temperature, but you run the risk of burning or melting the foam instead of cutting it cleanly. You need to pull the hot wire cutter very slowly through thick material. Because of its very thin wire, they tend to snap if you get too aggressive with your movements, so be careful. This is a neat tool, but it does take some practice and getting used to. If you're not careful, you could ruin a project with this, so think twice before you use it. There are many different versions of these in various price ranges and sizes available. Check online for more information. Before we go any further, you should know, this foam is very messy to work with. It creates a lot of fine dust particles that are not safe to breathe in. So before you start any project, you're going to need a dust mask of some sort. Here are a few that work. The disposable type is the easiest to get and use, and the least expensive of all the masks. Masks with replaceable filters are even better, but they can get pricey and harder to find, and you have to replace the filters often. So choose the one that works best for you and is in your price range. Let's look at shaping the foam. When you need to start cutting out shapes, a sharp utility knife is invaluable. Not only is it used for cutting, but also for basic carving and removing of small amounts of material. Hand files are also great. Use the ones that are coarse or rougher. They are great for shaping and removing material. Before we go further, let's take a closer look at the files. This is a rasp. It has few teeth spaced apart for very quick removal of foam. This is a wood and metal file with smaller teeth closer together for a medium cut. This is a metal file with very small teeth close together for a very fine cut. Let's see them in action. The rasp is very aggressive and leaves behind a very rough surface that will need a lot of sanding later. The wood and metal file has a finer tooth and leaves behind a smoother surface. This still requires some sanding later. The metal file's teeth are very close together and not very good for working foam. Foam is too soft a material for this file, and it doesn't really work any better than the wood file. So to save yourself some trouble, stay away from this. If you need to remove material fast, Sureform planes are probably the best. They have a cheese grater-like cutting surface that carves through foam really quick. The only drawback is the surface is very rough and they make an awful mess. They come in a variety of shapes and sizes. Check your local hardware store. To clean up all the rough surfaces left behind from the cutting and the shaping, we're going to need some sandpapers. This is a sanding sponge. It's a dense, spongy material coated in sandpaper of various grits. It's great for sanding organic shapes and foam surfaces because of its ability to conform to curved surfaces. These are sanding blocks. They are 80 grit sandpaper that have been glued to different sized blocks of wood. These are perfect for sanding flat surfaces or for flattening surfaces that are irregular shapes. Sanding blocks are great because you get to make them yourself, so you can get any size or shape you need. Here are a few examples of some custom sanding blocks I made. Some have two different grits on them. Then there's just regular old sandpaper. Lay it on a flat surface, and that'll help sand things flat, or use it handheld for irregular shaped surfaces or fine detail work. Those are the methods for cutting and removal of material. Make sure you work safely with the tools. They are all very sharp. Foam is very messy. Work in an appropriate space like a workshop or a garage, not your living room or bedroom. You will regret it. Let's move on to the next section. Let's talk about glues. Let's look at what glues work and which ones don't. Pink foam is a great material, but when it comes to gluing it together, it's very picky. We're going to cover the basics, the easy to get glues. The best glue by far is contact cement. There are two types. One works and one does not. Let's look inside. You can see they look very different. One looks like thick milk and the other like molasses. This one is water-based. This one is solvent-based. What does that mean? Both liquids will evaporate and leave behind the glue, but one does it without destroying the foam. I'll put a small amount of each glue onto the foam and we'll wait and see what happens. You can see that the solvent one is starting to fizzle almost immediately. That means it's eating its way into the foam surface. It's been sitting for a few minutes now, and you can see that the solvent glue has melted a large crater into the surface, whereas the water-based glue has not affected it at all. It's actually still wet. So the water-based one is the one you want to use. Let's learn how to apply it. First, we're going to need a disposable brush. The glue is hard on brushes, so don't use any one that you like. Both surfaces should be completely flat for this glue to work properly. The foam's factory finish is best. Try not to remove it. Spread out a very thin layer evenly over the whole surface of both pieces. Don't leave pools or blank spots. You don't need a lot of contact cement. A small amount goes a long way. You should be left with a shiny white surface when you're done. How contact cement works is both surfaces need to be coated thoroughly. When the cement dries, you put the two coated surfaces together and they become a permanent bond. This works best in a warm room. Do not do this in a cold basement or garage, or it will take a very long time for the water to evaporate off the foam surface. When buying contact cement, the large container is not always convenient. It is available in a smaller container like this one. It also comes with a brush conveniently attached to the lid, so you don't have to purchase any. So it's been a few minutes, and the contact cement has had time to dry. You can see that it is no longer white, but has dried to a clear matte finish. The surface is also sticky or tacky to the touch. It's now ready to use. Line up the parts you want to bond together. Do this carefully. You only get one shot at it. Once you touch the two glued surfaces together, they are permanently bonded. Apply a bit of downward pressure to the blocks to make sure that both faces touch completely. You now have a bond that's impossible to break. This technique will allow you to glue up multiple pieces of foam into giant blocks for carving your projects. Once the pieces are pressed together, you're ready to start working. Let's look at hot glue next. You might think this works great for foam, but you'd be wrong. The problem with hot glue is that it's hot. When applied to foam, it begins to immediately melt through. When it cools, it leaves a huge crater in the surface. A great glue for foam is PVA glue. It's another water-based glue that does not affect the surface of the foam, and it's great for gluing foam to itself. When gluing large blocks, make sure to cover the entire area with a thin, even coat. If you apply it too thick, it will take a really long time to dry. If you're going to use this instead of contact cement, this takes a lot longer to set up, sometimes hours, so plan accordingly. PVA will work for large block glue-ups, but contact cement works best for that. Use masking tape or elastic bands as a clamping device and then wait. If you plan on gluing small or thin pieces together, or to the surface of foam, they may require a little extra support. Wooden toothpicks are perfect for anchoring small parts that you want to glue together. They hold the piece while the glue is drying and support it after the PVA has cured. Poke holes on both surfaces where you want the pieces to live and then add glue to one surface. This technique is great for adding buttons or design features to surfaces, or for gluing handles or grips to larger bodies. You can see that the toothpicks really hold the buttons to the surface while drying. Let's take one last look at the hot glue, now that it has a chance to really cool down. Stay away from hot glue, it's not worth the aggravation. PVA glue is great for insulation foam, but it can also glue other materials to it as well, like foam core, illustration board, and Bristol board. All of these materials can be combined together to make high-quality sketch models for your design projects. Some time has passed and the PVA has had a chance to dry. You can see that it's gone clear. This is another great thing about PVA. It almost disappears when cured. And the bond is very strong between all these materials. Great shop guy, you showed us all this stuff, but what am I supposed to do with it? Well, let's put all those techniques to use. I'm going to make a simple and quick model and use as many of the tools and processes that we just discussed. We're going to make a hairdryer. It's a simple tube shape and a handle. Perfect project for foam. I figured out some of the basic dimensions. Then I glued together 2 blocks of foam using water-based contact cement. I then drew some lines and basic shapes of the tube onto the surface to guide me as I start to remove material and work it down to its final shape. Here are some basic tools to get started. Don't forget your dust mask. There's going to be a ton of sanding in this video. Sorry, but that's the nature of foam. As mentioned earlier, a sharp utility knife is great for basic carving and removal of large amounts of material. The foam gets very messy, as you will see. Keep cleaning up as you go, it helps, and it keeps the dust down, and it will make for an easier cleanup at the end of the project. I'm using a Surform plane to develop the surface and get closer to the shape. Keep checking the surfaces as you go to make sure you're maintaining the shape and symmetry in this case. Don't remove too much material at once because you can't go back. Once you sand it off, it's gone and it can't be put back on. The sanding blocks are for smoothing out rough surfaces left behind by the Surform plane and refining the shape. Keep checking for symmetry as you go. I go from an 80 grit sandpaper up to a 220 grit to get a smoother surface. I'm drawing on some guidelines to sand a 45-degree chamfered edge on each end of the main body. These lines will show me where to stop sanding so I don't go too far. The surface is nice and smooth and the edges are chamfered, so let's move on. We're going to work on the handle next. Make sure you have a piece that's bigger than you need. I'm going to create the mating surface between the handle and the main body of the hairdryer first. I'm doing this in this order because you don't want to spend a ton of time cutting and shaping a handle and then try to create the mating surface. If you mess that up, you may ruin the handle and have to start all over again. I'm creating more guidelines to chamfer the edges of the handle and create a more comfortable grip. The handle surface is smooth and chamfered, so let's glue the two together. We are going to use toothpicks to help hold the handle to the body while the glue dries and to give the connection some strength. Test your fit before you apply glue. I also have some elastics ready to go on the model, so I'm not fumbling for them later. Make sure you get good coverage over the whole surface, but don't add too much or it will ooze out when you squeeze the two parts together. Let this sit for a couple of hours before removing the elastics or tape. The longer it sits, the better. Carefully begin to remove the elastic or masking tape, and if given enough time to dry, the bond should be good and strong. You can end the model right here. It's got a nice surface finish and a well-defined shape, and that would be fine. We're going to take it one step further and add some detail made from other materials like foam core, illustration board, and Bristol board. They are just some simple shapes cut out and glued together. I won't go in on how to make these here because it would add a ton more time to this video. I do, however, have a video on how to work with these materials linked in the description below, so go watch that if you're interested. Let's start adding to the model. Details like these will help add visual interest to your models. Make sure you have masking tape or elastics handy for holding your parts onto the foam while the PVA glue dries. Again, apply enough glue to coat the surface, but not so much that it oozes out everywhere when you press the two parts together. That will make for a messy model. Make sure you let the glue dry for a few hours or more before you start handling the model. The longer the better. You don't want parts to start falling off on you. All done, and it's had plenty of time to dry. Carefully remove any tape or elastics and admire your work. Now, I went overboard and added a lot of extra stuff to this model just to show you the process. Yours may not need this much, but you can see what's possible. Insulation foam, when combined with other materials mentioned earlier, is a fantastic product that can help you realize your next design project's form and function quickly and inexpensively before committing to a final shape. Take advantage of these techniques and materials. If you want to paint your models, I have a video on how to do that as well. Link in the description. Hope this information was useful, and thanks for watching.